Dear students, welcome to our science episodes. Today we are going to continue discussing chemical equation and chemical reactions. Example 2. Magnesium plus oxygen. By heat, it will give magnesium oxide. And this is the symbolic equation. As usual, what are the reactants? The atoms to the left of the arrow, magnesium plus oxygen. And what are the products? The product here is the magnesium oxide to the right of the arrow. Above the arrow is the reaction condition, and this triangle represents heat. This is an unbalanced equation. First of all, the magnesium atom will give a magnesium atom after the reaction. But here it's an oxygen molecule consisting of two oxygen atoms. And this is an oxygen ion. So what are we going to do? Therefore, two magnesium atoms, two magnesium single atoms are needed to react with the molecule of oxygen, which consists of two oxygen atoms, to give two molecules of magnesium oxide. And now it's a balanced equation. Look to this equation. 2 magnesium plus oxygen molecule, it will give 2 magnesium oxide. Knowing that the atomic mass of magnesium equals 24 grams and the atomic mass of oxygen equals 16 grams. Therefore, the mass of the reactants to the left of the arrow and the products to the right of the arrow could be calculated. Let's calculate it together. 2 times 24, which is the atomic mass of the magnesium, plus 2 times 16, which is the atomic mass of the oxygen. On the right side, 2 times 16 plus 24. On the left side, it's 48 plus 32. On the right side, 2 times 40. On the left side, 80 grams, which is equal to the right side, 80 grams. This proves the law of conservation of mass, which says that the total masses of the reactants should be equal to the total masses of the products. 2 sodium atoms plus a molecule of chlorine, Cl2, will give sodium chloride. Knowing that the mass of sodium atom is 23 grams and the mass of chlorine atom is 35.5 grams. So, therefore, the masses of the reactants and the products could be calculated as well. Let's calculate it together. On the left side, 2 times 23 and plus or added to 2 times 35.5. On the right side, it's 23 plus 35.5. On the left side, it's 117 grams. This chemical equation does not keep the law of conservation of mass, simply because it's unbalanced. So for the equation to keep the law of conservation of mass, it should be balanced. And this is the right balance for this equation, that 2 single atoms of sodium will react with 2 atoms in a chlorine molecule to form 2 molecules of sodium chloride salt. Let's calculate it together. 2 times 23 plus 2 times 35.5. On the left side, 2 times 23 plus 35.5 on the left side. This is equal to 117 grams in both sides. Now this equation keeps the law of conservation of mass. Now let's discuss this example. Identify the molecular mass of calcium nitrate. Why now it's molecular mass? Before we call it atomic mass. When it is an element like hydrogen, sodium, magnesium, we call it atomic mass. But when it is a compound, we call it molecular mass because it's calcium nitrate. Produced from the reaction of 74 grams of calcium hydroxide and 63 grams of nitric acid, knowing that the molecular mass of water is 18 grams. First of all, the written equation, calcium hydroxide plus nitric acid, it will give calcium nitrate plus water. The symbolic equation, calcium hydroxide plus 2 molecules of nitric acid, it will give calcium nitrate plus 2 molecules of water. And this is a balanced equation, by the way. Let's calculate it together. 74 plus 2 times 63 on the left side, and the unknown molecular mass of the calcium nitrate plus 2 times 18, which is the molecular mass of water. On the left side, it's 200 grams. On the right side, it's the unknown plus 36. So on the right side, it should be 200 grams like the left side. Simply, the unknown is 164 grams, which is the molecular mass of the calcium nitrate. A compound is produced from a chemical combination between atoms of 2 or more different elements by constant weight ratios called the law of constant ratio. Let's see together. In this popular equation, 2 magnesium plus oxygen molecule consisting of 2 oxygen atoms, it will give 2 molecules of magnesium oxide. If you will calculate the atomic mass here, 2 times 24 plus 2 times 16 on the left side, then 2 times 16 plus 24 on the right side. This means that 48 grams of magnesium are needed to react with 32 grams of oxygen to produce 80 grams of magnesium oxide. So if we will shorten these numbers or divide them by 16, it will give us 3 to 2. So this means that the ratio of magnesium to oxygen in a chemical reaction to produce magnesium oxide is always 3 to 2. Therefore, 80 grams of magnesium oxide compound is produced by combining 48 grams of magnesium with 32 of oxygen. This ratio is constant. The 3 to 2 ratio is constant, and we call it the law of constant ratio. Now, calculate the mass of magnesium oxide produced from the reaction between 3 grams of magnesium and 5 grams of oxygen. From the previous slide, knowing that magnesium and oxygen react together by constant weight ratio, which is equal to 3 to 2. Therefore, 3 grams of magnesium should react with only 2 grams of oxygen, forming 5 grams of magnesium oxide. What about the remainder of oxygen? It will remain without reaction. 3 grams of oxygen will remain without reaction. Now it's time for questions. Fill in the blanks. When a magnesium ribbon is burned in air, it reacts with oxygen, forming a white powder of magnesium oxide. The chemical equation should be balanced to keep the law of conservation of mass. Now write the scientific term. It is the breaking of the existing bonds between the atoms in the reactant molecules and forming new bonds between the atoms of the product molecules. This is, of course, the definition of chemical reaction. It's a chemical equation where the number of reactant atoms of an element should be equivalent to the number of its atoms produced from the reaction. It's a balanced chemical equation. Thank you. Dear students, thank you for watching and see you later in other science episodes.